Hello world, welcome to TUC. My name is Abhishek Rajan. We are going to cover second part of Lambda expression. In this lecture, we are going to cover these many topics: putting Lambda into practice, type checking in Lambda, spatial word compatibility, and the function descriptor. And for your information, link for the first part of lecture has been provided in the description. So let's start with the first topic, that's putting Lambda into practice. All right. So you can see here in this code, what we are doing, we have a path. What is the path? It is the path for the file which we are going to read. All right, there are some content in the file, and using this path, we are creating a buffer reader object, which is getting created around the file reader. All right. So after creating the object, we are reading one line of the file. Okay, we are reading one line of the file and it is getting returned from here. All right, and when we call this process file retro and passing this path, it is getting called, and it will print the first line of the file. All right, so this is a very simple code where we are creating a buffer reader object, reading the line, and closing the buffer reader object. But this is kind of a big code, which is where a lot of try and catch we are writing. First one is here where we are reading the line, and then this is for the closing of buffer reader object. But when we use try with resource, we do not have to write this much unnecessary instructions. So let's go ahead with the try with resource approach, where we do not have to manually close the resource after reading the line. All right. So let's block this, and as we have our code using try with resource very concise and readable, we will opt that. So in this code, we are uh, we are using we are creating the buffer reader object and reading the line, and closing of the buffer reader object is automatically called after reading the line. All right. So this code is quite cool, but still it is not very flexible. Whenever we have to, let's say we are reading only one line of the file. All right, then up till now it's fine. Okay, later, let's say we have to read 5 lines of the file. All right, what we will do, we will have to write, because we do not have to delete this method, or we do not have to, modify this method. We will have to write one more method in order to do that. All right, so whenever we are writing one more, let's say we have to read 2 lines of the file. Let's say first we are going to execute this and see what is the output. We are executing this code, uh, compiling the code. Let's compile the code. Okay, it has been compiled, and now we are going to execute this. Let's take the package and dot. It's going to read one line of the file. All right. So let's say we have to read 2 lines of the file. What we can do? We will have to write one more similar method. All right. Let's copy this method and do that. So I have copied the method. Let's indent it. Sorry. It has been indented. And now what we have to do, we have to read 2 lines of the file, right? So let's do that. Insert one more read line, right? So this is how we have to do, which is very difficult to do every time whenever we have to read different number of lines from a file. All right, and we can see here the two things are going to be same. All right, only this instruction is going to be changed. Only this instruction is going to be changed, and rest of the things are going to be same, such as this creating the buffer reader object or opening the stream. All right, and then closing the stream. Here as well, the closing of stream is going to be called automatically. All right, so what we can see here, the observation is the opening and closing the resources are going to be same in each method, and only the difference is the meaningful operation. What is the meaningful operation? The reading of line operation. what we are doing, we are reading a line from the file which is going to be different for the different methods. All right, and this is called execute around pattern. So if we take a look here, this is the execute around pattern where the essential task is going to be where the essential task is going to be where this essential task is going to be this is the execute around pattern where the essential task is going to be encapsulated between the initialization code and the cleanup code. All right. So this is what we have to understand now, and we have to figure out how can we use this behavior which is changing every time, except the initialization and the cleanup part, the behavior which is changing every time, and how can we use that to parameterize the behavior in order to implement Lambda. And why we are trying to use Lambda? Because this code is limited. If we are writing this code to read one line of a file, it is limited. Or when we are writing another method in order to read two lines of a file, this code also is limited. All right. So in order to expand our wing, we will have to write a different sort of method where we will use Lambda expression. And in order to use Lambda expression, we will have to understand the behavior which can be parameterized. All right, so this is the behavior which is supposed to be changing every time. So this is the behavior which is changing, and this is the behavior which is supposed to be parameterized. All right, so this is the behavior we have to parameterize, and then uh, there are some specified approach. There are some specified steps in order to implement Lambda in our code. So first of all, we have to understand the behavior need to be parameterized. So this is the behavior, that is br dot read line. This is the behavior which is supposed to be parameterized. All right, and after that, using that, we will have to create a functional interface. Okay, so what is the functional interface? It is an interface where only one default method will be there, and that default method is supposed to be implemented, and that Lambda is going to be passed from the function. So whenever we create a functional interface, we will have to implement it. All right, so after implementing it, we will have to execute the behavior. So whenever we are implementing the functional interface, we are providing a behavior. We are providing a new behavior to that interface. All right, so and we will have to finally pass the Lambda. All right, so let's do that. So we will have to create an interface. Okay, so let's create an interface. Let's remove this. This is actually not required. So I have removed the method. So now I'm going to create an interface. So let's do that. Interface. Let's file processor. In here, we have to write a method. Okay, let's understand what is the method. What should be the method look like? What we are doing here, we are reading a line. Okay, and this line is going to be returned from here. All right, we can see here, this is the line we are reading, and we are returning it from here. So what it is returning? It is returning a string. All right, so essentially the method in the file processor should be returning a string. Okay, fine. Let's put a method named process. Okay. Now, this method, this behavior, I mean, the part which is changing, it is going to use a buffered reader object. All right. And on that buffer reader object, it is invoking the readline method. Okay. So this method should take an argument of buffered reader type. Okay. So let's take an argument of buffered reader type. All right. So we have understood the behavior which is supposed to be parameterized. We have created the interface, and now let's implement this functional interface. And for a better practice, let's use the annotation as well. Fine. So it has been done. Now let's implement this interface. Let's implement it. So how can we do that? So first of all, we need to have a variable of file processor type, fp, let's say. Now we have to implement it, so we will have to take this list of argument from here, and the arrow token and the body of Lambda. So what should be the body of Lambda? Basically, this will be the body of Lambda. All right. And since there is only one argument, first of all, we need this data type is not required. It has been removed. And since there is only one argument, so this small bracket also is not required. So let's remove it. Now let's save it. Further, what we have to do? We have all these three things has been done. All these three things has been done. Okay. Sorry, only first and second part has been done, right? Now let's execute the behavior. Okay. Third part we are going to do. Let's execute the behavior. How can we execute the behavior? We can execute the behavior on this FP object. FP dot process, and in here we pass BR. All right. And essentially what we have to do, we have to throw the IO exception actually, because we are implementing this functional interface and we are invoking the readline method. All right, so it should throw IO exception. Let's throw it. Sorry. Let's take this from here and let's paste it. Fine. Now what we have to do, we have to execute the behavior here. All right. We are covering the third step. Let's execute the behavior, and it has been done. We have executed the behavior. Now what we have to do, we have to pass the lambda. How we can pass the lambda? By passing this functional interface type variable FP. All right, and here also we will have to have that variable type. All right, so this is done. What we have done, first of all, we have understood the behavior supposed to be parameterized. All right, we have understood that. Then what we have done, we have created a functional interface, and then what we did, we executed the behavior, created the functional interface, and we will have to implement that functional interface. Implement as well, and then we have to execute the behavior and then pass the lambda. All right, so we have passed the lambda here. Now we can execute this. All right, but since it was same as before, so let's read two lines at a time now. All right, so let's do that. br.readline. Fine. Now let's try to compile this code. Sorry, let's try to compile this code. Java C -d dot process file. Oops, Java C. It has been compiled. There is no compilation error. All right, let's execute it. Java dot process file AX. Okay, this is reading two lines of a file. This is India. India is great. It is coming in a same line. So let's put a new line character between this concatenation operator. Insert \n. Let's compile it again. Here you go. It's a very cleaner output. This is India. India is great. This is how we can read two lines of a file. So this was for the two lines of a file. And if we have to read more than, apart from this, let's say we have done this and we have called this and we are getting the output by reading two lines. And if we have to read a single line, we can simply create another, we can simply implement this functional interface with this implementation where we are reading only one line of a file, and we are calling the process file method with this fp2 file processor type. And if we have to read three lines of a file, we are implementing another one more time we are implementing this functional interface where we are reading three lines of a file, and we are calling this process file method with this mp3. So here we are not changing in this code. This process file method is not going to be changed. Only we are implementing this lambda in different way, so that every time we in a different way, so that we can read different number of lines of the file. All right. So if we take a look at the output, so let's compile the code first. It has been compiled. Now let's execute it. So this is the output. This first output is for this process file method, that is 34th line, where it is reading 2 lines of a file. Then again, we are executing the 35th line, where we are reading only 1 line of the file, and then we are executing on 36th line, where we are reading 3 lines of a file. You can see here on 32nd line we are reading 3 lines of a file, so it's reading 3 lines of a file. All right, so I'm going to mark this as done, as it has been covered. Now let's talk about other topic, that's type checking in Lambda. All right, we have a list of integers, and there are some even and odd numbers in this list, and we are calling stream method on this list of integers, and we are getting a stream from that, and on that stream we are calling a filter method. All right, so in this filter method we have some lambda. Okay, so basically the type of lambda is deduced from the context in which this lambda has been used. Okay, so what is the context this lambda has been used in? It is filter method. Okay, so first let's understand what is the signature of this filter method. Okay, so we can come here and we can see here, this is the filter method. All right, so in this filter method we have the predicate interface. It takes it this whatever we are doing, it is basically the implementation of this predicate interface. All right, this is basically the implementation of this predicate interface. So this filter method accepts a predicate, the object of a predicate, all right, the implementation of a predicate. Okay, no problem. So now we saw that the target type is predicate here. All right, the target type is predicate here, and the predicate, it is the predicate is so if we come here, then the predicate target type, the predicate t, and t is bound to integer for in our case. All right, and what is the method in this predicate? It is the test method. Okay, and this test method takes a parameter t, parameter of type t, and it returns a value of boolean type. All right, so basically this is our interface. All right, and this predicate is our interface, and this t is integer for us. Okay, and this is the test method. So what is the function descriptor for this test, for this method? It is t, takes an argument of type t, and returns a value of type boolean. All right, and in our case it is integer and boolean. So when we take a look at this at this uh, at this lambda, so basically what we are doing something like takes takes an argument e, and does some check whether it is boolean or not. 0. So this results in a boolean value, and this is the integer. So this, the signature of the lambda, the function descriptor and the signature of lambda is matching. Okay, the function descriptor and the signature of lambda is matching. All right, so the code type checks here. Okay, so in order to do this, what we have to do, first of all we have to understand what is the context this lambda has been used in. Okay, and then we got that it is the predicate interface. And how did we understand it is predicate interface? We saw the signature of this filter method. Okay, and in predicate interface, what is the method? This is the test method. And what is the descriptor, function descriptor of this test method? It is integer boolean for our case. Okay, and when we saw the lambda, it is what lambda we have written, it is e mod 2 e. This is what we are accepting as an argument. This is the arrow token, and e mod 2 double equals 0, which is a boolean, which is resulting in a boolean value. So this is how the function descriptor and the lambda is matching. So this is how the code type checks. I'm marking this as done because this has been done. Now let's talk about the third point, spatial word compatibility. All right, we have two interfaces. First interface is this, which has a functional method. First method, which takes string as argument and returns a boolean value. Second method is second interface, and which accepts a string argument and returns a word. All right. So what this spatial word compatibility states, if a lambda has a statement expression as its body, if a lambda has a statement expression as its body, all right. So what does it mean? Basically, what we have to do. mm, so let's try to implement these methods in such a way that it calls some other method. All right. So let's take another method. All right, which works on the string, and that method is it basically checks whether the length of the string is greater than 10 or not. All right. So it should return boolean. All right. Public boolean find length str, and in here what it does, it returns str dot length if it is greater than 10 or not. All right. So as I said, the if the lambda has a statement expression as its body, all right. So basically the lambda, whenever we are trying to implement this first interface, all right, first interface equals, we have to implement this interface using lambda expression. So what we are doing, we're taking a list of argument, and what we are doing, we are calling this you know this find length method on the as the body of lambda. All right. So this is what the expression statement means. So we are calling one method from the body of lambda, that's find length. All right. So how can we call this method? Basically, we can do something like mm, find find length. All right. So okay, let's create this as a static. All right. So find length, and in here we are passing some string. Okay, this string we are passing, actually this is a single argument, and first the data type is not required, and then the small bracket also is not required. All right. So let's implement the second interface as well, and there also it should have the statement expression. All right. So here also we are doing something like this, and this is the second interface, so let's remove it, and this is the second interface. All right. And let's call these methods. If I dot first method, it is uh, India, and I si dot second method, sorry, this is not interface, this should be method, and in here we have to pass this method. All right, second method, and inside this we are saying like this is amazing. Okay, fine. So how this works, we will have to find this out. All right. So let's see, by executing this, let's annotate with this functional interface annotation at the rate functional interface, and here as well we need to annotate it using functional annotation, functional interface. This has been annotated, and let's execute this. It's compiled first. What does it? Sorry, public static boolean it should be. It's running without any error. All right. So basically, this is one of the examples of this, that if we have the statement expression as its body, then this it is compatible with the void. All right, because this is returning boolean and it is going to be compatible with the void. One more example is, let's create a list of string and list of, sorry, new array list, type infer. Okay, now we can do something like, okay, so we have two interfaces, one is predicate and one is consumer. The predicate interface takes an argument. All right, predicate interface takes an argument uh, of type t, so here it is string for our case, and predicate, and it returns a boolean. All right, so let's do something like, how to implement this. Let's do something like str, and it returns a boolean. All right, so list dot add str. Okay, this is the first one. So here we are we are taking a string as an argument, and we are adding that string to the list which is of string, which is the list of a string. All right, and this is the one which we have implemented, and we can do that with the consumer also, because consumer takes some argument. In our case it is going to take a string argument, and it does not return anything. It returns void. All right, so that also will be compatible. Okay, so consumer string equals str is dot add str. Right, so let's import this consumer and predicate. So let's import java.util dot function dot consumer, and another is predicate. Let's execute this. Oops, what is the problem? Oh, there is a spelling mistake here. Oops, sorry. Ti. Let's compile this. Cannot find symbol. Oops, I took another. Sorry, let me change this list. Okay, no, it works. So what we saw, if the lambda has a statement expression as its body, it is compatible with the with the with the function descriptor, which returns void, provided the parameter list is compatible too. Right. So this is how the it is getting compatible. So we can see here, uh, this is this this predicate returns a boolean value, and this consumer returns a void, but it is becoming compatible because the lambda body of lambda is having a statement expression provided the parameter is compatible to. The parameter should also be compatible. Here also the parameter is compatible. All right. Here also the parameter is compatible. So this is how it is uh, going to be compatible. The void type is also going to be compatible. All right. Now let's write the function descriptor for some of the interfaces. We are going to do some hands-on on this. If you have understood clearly, from the previous lecture, then you can omit this. You can leave this. All right. So when we have to write a function descriptor for an interface, we will have to look at the method of that interface. All right. We will have to look at the functional method of that interface. So this is a functional method, and what we have to how we have to write. First of all, we'll have to take the list of arguments s. All right, a string, sorry, it's a string. And what does it return? It returns a value of boolean type. It takes an argument of type string. So on the left side of the arrow token, it will be string, and on the right side, the return type, it is boolean. All right, boolean. This is how we have to write the functional interface, function descriptor for the functional interface. All right. So let's now write for this predicate. What should be the function descriptor for this? So we can see here the test method. It takes an argument of type t. So there will be one arrow token, and on its left side, t will be the type, and it returns it returns a value of boolean type. So on the right side of the arrow token, it will be boolean. All right. Now for this consumer interface, we have the accept method. This accept method takes an argument of type t, so definitely it will be an arrow token. On the left side of it, it will be t. All right. And on right side, what it should have, it is a void. It returns a void, so it will be void. All right. This is for this, and this is for this. Now let's write for the functional interface. So this is the apply method, which takes an argument t and returns a value. It takes a value of type t and it returns a value of type r, meaning what it accepts is different from what it returns. All right. So this is for this we can write it as t arrow token r. All right. Now for this supplier, we can write something like it doesn't take anything. All right. So we can say something like empty bracket, an arrow token, and it returns a value of type t. Great. Now for this by predicate, we have the method test. Okay. So we can do something like t comma u. It takes two argument and it returns a boolean. All right. Now for this by function functional interface, it accepts two values. Of one is of type t and other is of type value v. All right. So we can say that t comma, sorry, it accepts two values. One is of type t and other is of type u. So it should be t comma u, and it returns a value of type r. Okay. So basically, this is different from what it takes. All right. For by consumer, how can we write? It takes two arguments t comma u, and it returns a void. All right. So you can try with yourself also how to write the function descriptor for these interfaces. And with this, we are going to conclude the second part of Lambda expressions. Thanks for watching. Bye bye.